Learning the C++ computer programming language. Part 13: Dynamic memory. A learn by listening exercise. From worldwideweb.com/doc/tutorials/dynamic/ open parenthesis. If you haven't already seen or heard the previous chapters in this series, you should do so before proceeding here, as it will help you understand the context and unusual format of this presentation, which is optimized for listening so that you don't necessarily have to watch the video. Close parenthesis. In the program seen in previous chapters, all memory needs were determined before program execution by defining the variables needed. But there may be cases where the memory needs of a program can only be determined during runtime. For example, when the memory needed depends on user input. In these cases, programs need to dynamically allocate memory, for which the C++ language integrates the operators new and delete. Operators new and new left square bracket right square bracket . Dynamic memory is allocated using the C++ operator new. The operator keyword new is followed by a data type specifier describing the way individual elements of the block are expected to be referenced and if a sequence of more than one element is required, a number of these within brackets left square bracket right square bracket. If the requested memory is available, new returns a pointer to the beginning of the newly allocated memory block. The syntactical forms of new are : example 1 of pointer equals new type, semicolon. Example 2 of pointer equals new type left square bracket number underscore of underscore elements right square bracket, semicolon. The first example is used to allocate memory to contain one single element of the designated type. The second one is used to allocate a block, open parenthesis, an array, close parenthesis, of elements of the designated type, where number underscore of underscore elements is an integer value representing the number of elements of the corresponding type that will be contained within the block. Consider the following line example : line 1 of and asterisk, foo, semicolon. Line 2 of foo, equals new int left square bracket 5 right square bracket, semicolon. In this case, the system dynamically allocates space for 5 elements of type int and returns a pointer to the first element of the sequence, which is assigned to an integer pointer named foo, Therefore, foo now points to a valid block of memory with space for 5 elements of type int. Here, foo is a pointer, and thus, the first element pointed to by foo can be accessed either with the expression foo, left square bracket 0, right square bracket, or the expression asterisk, foo, open parenthesis. Both are equivalent, close parenthesis. The second element can be accessed either with foo, left square bracket 1 right square bracket or asterisk, open parenthesis, foo plus 1, close parenthesis, and so on. There is a substantial difference between declaring a normal array, as shown in previous chapters, and allocating dynamic memory for a block of data using new. The most important difference is that the size of a regular array needs to be a constant expression, and thus its size has to be determined when the program is written, before it is run. Dynamic memory allocation, on the other hand, as performed by new allows allocation of memory during runtime using any variable value to determine its size. The dynamic memory requested by our program is allocated by the system from the memory heap. However, computer memory is a limited resource, and it can be exhausted. Therefore, there are no guarantees that all requests to allocate memory using operator new are going to be granted by the system. C++ provides two standard mechanisms to check if the allocation was successful: one is by handling what C++ calls exceptions. Using this method, an exception of the predefined type bad underscore alloc is thrown when the allocation fails. In this context, the word thrown allows branching out to a new area of code, known as a handler, that can be specially written as part of any program to report or handle problems like running out of memory. Exceptions are a powerful C++ feature explained in further detail later in these tutorials. But for now, you should know that if this exception is thrown and it is not handled by a specific handler, the program execution is terminated. This double quote, exception double quote, method is used by default by double quote, new double quote, comma, and so is always used in a declaration like this one colon. Foo equals new in left square bracket 5 right square bracket, semicolon, slash, slash, if allocation fails comma, an exception is thrown. The other method is known as double quote, null throw double quote, comma, and when new is used and a memory allocation fails comma, double quote, new double quote, returns a null pointer instead of a pointer to newly allocated memory. Program execution then continues with the next statement from the source code, open parenthesis, which should check for this double quote, null pointer double quote, situation and take steps for error reporting or orderly shutdown comma, etc. Close parenthesis. This method can be specified by using the special keyword double quote, null throw double quote, comma, declared in header left angle bracket, new right angle bracket, comma, as an argument for new. Here's an example colon. Foo equals new, open parenthesis, null throw, close parenthesis, in left square bracket 5 right square bracket, semicolon. In this case, comma, if the allocation of this block of memory fails comma, the failure can be detected by checking if foo is a null pointer. For example comma, consider these 6 lines colon. Line 0, 1 of 0, 6 in asterisk, foo, semicolon. Line 0, 2 of 0, 6 foo equals new, open parenthesis, null throw, close parenthesis, in left square bracket 5 right square bracket, semicolon. Line 0, 3 of 0, 6 if, open parenthesis, foo equals null ptr, close parenthesis. Line 0, 4 of 0, 6 open curly brace. Line 0, 5 of 0, 6 slash get here, if memory cannot be allocated for double quote, foo, double quote. Take measures. Line 0, 6 of 0, 6 close curly brace. This null throw method is likely to produce less efficient code than exceptions comma, since it implies explicitly checking the pointer value returned after each and every allocation. Therefore comma, the exception mechanism is generally preferred comma, at least for critical allocations. Still comma, most of the coming examples will use the null throw mechanism due to its simplicity. Operators double quote, delete double quote, and double quote, delete left square bracket right square bracket double quote. In most cases comma, memory allocated dynamically is only needed during specific periods of time within a program, semicolon. Once it is no longer needed comma, it can be freed so that the associated memory block becomes available again for other requests. This releasing of allocated dynamic memory is the purpose of the C++ operator double quote, delete double quote, comma, whose syntax can take two different forms like these examples colon. Example 0, 1 of 0, 2 colon delete pointer, semicolon. Example 0, 2 of 0, 2 colon delete left square bracket right square bracket pointer, semicolon. The first example above releases the memory of a single element allocated using new comma, and the second one releases the memory allocated for arrays of elements using new and a size in brackets, open parenthesis, left square bracket right square bracket, close parenthesis. The value passed as argument to delete must be either a pointer to a memory block previously allocated with new comma, or a null pointer, open parenthesis. In the case of a null pointer comma, delete produces no effect, close parenthesis. Here's a 30-line sample program illustrating use of double quote, new double quote, and double quote, delete double quote. Line 0, 1 of 30 colon slash remember dash, o dash, matic. Line 0, 2 of 30 colon pound sign, include left angle bracket, iostream right angle bracket. Line 0, 3 of 30 colon pound sign, include left angle bracket, new right angle bracket. Line 0, 4 of 30 colon using namespace std semicolon. Line 0, 5 of 30 colon. Line 0, 6 of 30 colon int main, open parenthesis, close parenthesis. Line 0, 7 of 30 colon, open curly brace. Line 0, 8 of 30 colon in I comma, and, semicolon. Line 0, 9 of 30 colon in asterisk, b, semicolon. Line 10 of 30 colon C out, double left arrow, double quote, please tell me how many numbers you would like to type colon double quote, semicolon. Line 11 of 30 colon C in, double right arrow I, semicolon. Line 12 of 30 colon B equals new, open parenthesis, null throw, close parenthesis, in left square bracket I right square bracket, semicolon. Line 13 of 30 colon, if, open parenthesis, B equals null ptr, close parenthesis. Line 14 of 30 colon C out, double left arrow, double quote, error, memory could not be allocated double quote, semicolon. Line 15 of 30 colon else. Line 16 of 30 colon, open curly brace. Line 17 of 30 colon 4, open parenthesis n equals 0 semicolon, and left angle bracket, I, semicolon, and plus closed parenthesis. Line 18 of 30 colon, open curly brace. Line 19 of 30 colon C out, double left arrow, double quote, enter number, double quote, semicolon. Line 20 of 30 colon C in, double right arrow P left square bracket and right square bracket, semicolon. Line 21 of 30 colon, close curly brace. Line 22 of 30 colon C out, double left arrow, double quote, you have entered, double quote, semicolon. Line 23 of 30 colon 4, open parenthesis n equals 0 semicolon, and left angle bracket, I, semicolon, and plus closed parenthesis. Line 24 of 30 colon, open curly brace. Line 25 of 30 colon C out, double left arrow, B left square bracket and right square bracket, double left arrow, double quote, comma, double quote, semicolon. Line 26 of 30 colon, close curly brace. Line 25 of 30 colon delete left square bracket right square bracket B, semicolon. Line 26 of 30 colon, close curly brace. Line 27 of 30 colon return 0 semicolon. Line 28 of 30 colon, close curly brace. When this program was executed, as expected comma, the following output was generated colon. Please tell me how many numbers you would like to type colon 5. Enter number colon 75. Enter number colon 436. Enter number colon 1067. Enter number colon 8. Enter number colon 32. You have entered 75, 436, 1067, 8, 32, Notice how the value within brackets in the double quote, new double quote, statement is a variable value entered by the user, open parenthesis, I, close parenthesis, not a constant expression. It was declared with the following statement colon. B equals new, open parenthesis, no throw, close parenthesis, in left square bracket I right square bracket, semicolon. Of course, the user might possibly introduce such a huge value for double quote, I double quote, that the system cannot allocate enough memory for it. For example, when I tried to give a value of 1 billion to the double quote, how many numbers double quote, question, my system could not allocate that much memory for the program, and I got the text message we prepared for this case, open parenthesis, double quote, error, memory could not be allocated double quote, close parenthesis. It is considered good practice for programs to always be able to handle failures to allocate memory, either by checking the pointer value, open parenthesis, if no throw, close parenthesis, or by writing an appropriate double quote, handler double quote, routine to double quote, catch double quote, the proper double quote, exception double quote. Dynamic memory in C. C++ integrates the operators double quote, new double quote, and double quote, delete double quote, for allocating dynamic memory. But these were not available in the classic double quote, C double quote, language, semicolon. Instead, it used a library solution, with the functions double quote, malloc double quote, double quote, calloc double quote, double quote, realloc double quote, and double quote, free double quote, defined in the header left angle bracket, stdlib right angle bracket, open parenthesis, known as left angle bracket, stdlib. H right angle bracket, in C, close parenthesis. Those functions are also available in C++ and can also be used to allocate and deallocate dynamic memory. Note, that the memory blocks allocated by these old double quote, classic double quote, C functions are not necessarily compatible with those returned by double quote, new double quote, so they should not be mixed, semicolon. Each one should be handled with its own set of functions or operators.